So we'll discuss about why BGP, basically in terms of when we have different autonomous systems. Between the different autonomous system, why we need BGP, why not a routing protocol like IGP, right? So before we discuss that, let's talk about few basics thing, and then we'll gradually move forward based on why we need BGP. So first, in the routing world, when we talk about routing protocols, so routing protocols, basically one is your IGP, interior gateway protocol. The other one is basically EGP, right? Exterior gateway protocol. So difference between these two protocols are, so IGP is considered to be worked within an autonomous system, and EGP is basically between the autonomous system. So the primary difference is this one. So for example, for let's say in protocol context, right, for OSPF and ISIS, for a routing protocol perspective, right, what is a routing domain called as? So routing domain or an autonomous system, right? So I'm just saying about the routing domain perspective for this ISIS and OSPF. So for them, this is nothing but, for them, this is an area in which they will flood the topology information. So topology information between within an area, right? When we talk about BGP, right? BGP says that a routing domain is nothing but having a same administrative control. So we will have a same administrative control with context of BGP, whereas for ISIS and OSPF, when we talk about a routing domain perspective, it's a topology information. They will flood, it's an area in which they will flood a topology information in that. Another thing is, so what is a routing domain is in this scenario? For example, this is an autonomous system, right? And this is a part of 65001. This is another autonomous system. Let's say this is an autonomous system of customer A, and this is an autonomous system of customer B, right? And you are a network engineer and you are working in this organization for customer A, right? You will have the authority for the configuration, as well as you will have an authority to manage it, like operation things, knock thing, everything, right? But as a network engineer, being a part of organization A, you will not go for B and do the management, right? So whatever devices that you are taking control of and you are managing of, so basically that is a part of the same routing domain. So for BGP perspective, when the routers or the devices, right, under a single administrative control, this is what refers to as nothing but an autonomous system. So this is what we're calling as routing domains, or we can say that BGP context, we can say that this is an autonomous system. And in every autonomous system that we have, we are giving a unique number to it to identify it. Okay, so coming back to the context of why not for this, for example, when A wants to communicate with B, why not a single routing protocol will be there, right? For example, A wants to communicate with B, and this is his own autonomous system. This is the A autonomous system. So why not we will go ahead and use a single routing protocol, like single routing protocol as in single IGP, let's say, like for example, we'll use as RIP or ISIS or let's say OSPF. So why not this protocols across? Okay. So for example, let's take an example here. A wants to communicate with B, and for example, this autonomous system is not a transit autonomous system. Transit as in, so nobody will pass through. For example, A wants to communicate, so A will not go ahead and bypass this autonomous system and then it will come here, right? So basically our path is what we refers to as, if A wants to communicate, the path will be like this, okay? Not through 65003, which is not a transit autonomous system. Okay, so in this case, first of all, is we need to have an advertisement. So the route, for example, 15.1.1.0/24 is a prefix that need to be advertised, right? If it needs to be advertised, so R11 will advertise. So it will advertise till in this autonomous system, it will advertise via this, then this will advertise to this will advertise to this one. So R1 is the first hop in the router, right? First hop for A in order to communicate. So R1 needs to have the route in the routing table. So in the route table, we should have 15.1.1.0/24, right? How that route is coming from? So basically the route which is coming from is what? Based on advertisement. So advertisement is done by whom? A routing protocol. Either these routing. So we are discussing about a single routing protocol. So they are advertising that. So they are providing the reachability information. Based on this reachability information, your route table has been formed. And based on this route table will give you the path. Which path it will carry from, for example, A wants to communicate, which path it will go through. So here is an important concept to know is the advertisement part is what we refer to as a control plane. Okay. So basically, whenever B advertises his own subnet through a via routing protocol, that is what is a control plane. Without the route, you will not able to move further, right? So this is a control plane. And at the same time, when A wants to communicate with B, for example, A is here, B is here. So when A wants to communicate with B, then this is what refers to as a data plane. So what is the significance of this arrow mark? It is, remember, it is always, the control plane is always opposite to the direct data plane or the forwarding plane. So forwarding plane or data plane is when we are sending any data. Control plane is how we are learning that particular route. How we are learning based on, for example, based on the routing protocols that we have. Okay, so this is very important concept to know, control plane and data plane. Okay, now for example, route has been learned and there is traffic flow end to end is there. So control plane, data plane is absolutely fine, right? Now there is a requirement says that this autonomous system is not a transit autonomous system. So it will not going to use this link for traffic forwarding, right? For the traffic, if it will not use this link as traffic forwarding, so we have only one option left. This is the link that we will go ahead, or this is the autonomous system 65002 autonomous system that will go ahead in order to reach A, in order to reach to B. From an advertisement perspective, how we can stop the traffic to go via this path. So we will have an option. We'll go ahead and apply a filter. So what kind of filter you will apply here? So we need to apply a filter in control plane, right? So which is a filter in terms of the route table. So whenever there is an advertisement, it should block over here. So that in our routing table, we will have only one route via 65002, right? So we'll apply a filter. Whenever we are applying a filter, it should be managed by someone, some of the administrators, some of the network engineers, right? Now, for example, there are thousands of routes over here. What will happen here? So we need to add those number of filters again and again. And then we need to maintain that filter as well, right? For instance, while maintaining, while configuring, something went wrong. Some other, for example, you remove a filter and then it starts like from, for example, this starts advertising, the data plane will start going through this and reaching here, right? If there is some problem with the filter. So because this is what we are doing manually. So in order to solve this problem, basically what we will have, we'll leverage BGP. Okay, so for BGP, world, so the routers under a single point of administrative control are referred to as a autonomous system. So this is one autonomous system, this is another autonomous system, or this is another autonomous system, right? Now, so basically when we talk about autonomous system, first thing is, right, whenever we're talking about autonomous system should look like a single thing from outside. It will look like a single entity from outside. For example, let's say 1.10.1.10 route is advertising from this. So we receive it from here, 1.10.1.10. We also receive it in here, 1.10.1.10, right? So we receive the routes from where we are receiving it 65003. We are receiving it 65003, right? If you look at the route in autonomous, sitting at autonomous system 65001 at R3, you saw that it learned from 65003. If you look at R10, it is also, you will see that, okay, this is, even though you are learning it from two different routers, but they are from a single autonomous system, right? So an autonomous system will look like a single thing, for example, right? And based on this single thing, like it will look like a single device from which you are learning, even though we have multiple devices inside it. For outside world, it will always look like a single thing, right? So what that makes an autonomous system, the edge router, these are all what called as edge devices, right? The edge devices in which the peering are, so basically those edge devices will have same policy in that, so that it will look like a single thing or single box from outside. For example, we have a customer routes. These are all what referred to as a customer routes. And inside your autonomous system is what refers to as a infra routes, right? We have infra routes, we have customer routes. What options that we can go with? If we go with single routing protocol. If we go with single routing protocol, then we need to redistribute these routes across everywhere, right? Entire internal, external, all routes should be redistributed, right? For example, if we have here, let's say 500 routes, here we have, let's say 500 routes, here we will have 500 routes. In order to have a communication for A to B, we need to redistribute and increase the scale of each router, which is like, let's say 1500 routes after redistribution. Okay. This is just a depict of a topology. Let's say if you talk about, when we talk about internet, so where we have like millions of routes, right? And if you are using a single routing protocol, then basically we need to redistribute everything. Think about each and every router, what will be the scale and what will be the health of each and every router having so many routes, right? So if we have an internet perspective and we are redistributing with a single routing protocol, then it's not a good choice to do it. Another thing is, what will be the convergence perspective? So we need, for example, if this link goes down, so immediately we will have another link to be there in place for the forwarding, right? So implementing a convergence within an autonomous system, we can achieve through OSPF and ISIS faster convergence, right? For example, if you're talking about an internet route where millions of routes are there, then it is not possible to achieve speed of convergence, right? So that is the main reason why we will use point number 5, why we will use, for example, IGP routes for the infra network and the customer routes for the used by BGP. So for example, if we are using like IGP within an autonomous system, and for this customer routes to advertise by BGP, we will achieve, first of all, the speed of convergence which is required within an autonomous system. So what we can achieve is the speed of convergence. Okay, so speed of convergence within an autonomous system will be the required first place, right? We do not, if it is a, we know that if it is an internet routing table, is entire internet routing table is there, we need to stable, we do not need to have a trigger update and all for those, right? Second thing is, if we are doing for example IGP for your infra routes and BGP for your customer routes, so what we are doing, we are separating the failure domain. So we have separate failure domain somewhat based on BGP for the customer routes and IGP for the infra routes. Another thing is also, we are not redistributing these routes across. For example, if we have like 500 routes over here, 500 routes over here, 500 routes over here, we are not redistributing. In order to communicate A to B, we are not required to redistribute entire autonomous system to another one, right? We will have our own routes within an autonomous system, and we are making a communication through. So possibility, for example, A to B, it will communicate, it will go like this. So going back to the previous topology, right? Previous discussion point. Now what we want is, the requirement is in this perspective, right? We do not transit this autonomous system. So what protocol that we will have? We have BGP. So we have BGP, and based on BGP, we can have route influence policies. We can leverage attributes of BGP in order to do whatever we want to do based on the incoming and outgoing for this device itself. So we will ignore this one. No need, not required of any kind of policy or filters over here. For instance, let's say tomorrow what happened is, we are A to B communication is fine, so it is down. To make, basically to till the time it will restore, right? So traffic will start moving from this direction. Even though, for example, for the time being, right? For the time being, in order to restore the traffic, restore the connection, till the time there is no loss, so that we can leverage this autonomous system to cater the traffic. That gives you a kind of redundancy perspective. So another scenario is, what all scenarios that we need to have BGP to be configured, right? For example, this is one of the customer A, right, which is having a dual homing scenario for two different ISPs. This is one customer which is having, for example, one peering with the ISP, right? So do you think that if we go ahead and use BGP in this case? So basically in this kind of scenario, we can advertise a default route and then we can manage it. Not required, because a single homing perspective, right? When we have a dual homing kind of thing, there what we can go ahead and use BGP. So BGP, and then based on the BGP attributes that we will have, we can have multiple use cases, like the incoming will be this side and outgoing will be this side, or incoming outgoing from one link. So multiple scenarios can be done, right? So in terms of A to B communicate, for example, in terms of A, if it will have a multi-homing scenario, we can use BGP in this. If it is single homing, we can also go with a default route, a static route. So what all things that we discussed so far? We discussed that we have different routing protocols, right? Based on different routing protocols, we have IGP and we have EGP. So what is, basically we also discuss about what is routing domain. Then from a protocol perspective, right? So let's say for ISIS and OSPF, what is a what is basically routing domain look like for a BGP context? What is a routing protocol? What is the routing domain look like, right? What is the autonomous system? We'll discuss more about this, but here also we discuss. Based on this, we discuss about the control plane and data plane. So remember, this is a very important concept, control plane and data plane flow. Control plane is always opposite to the data plane. We also discuss about like what will happen when we will use a single routing protocol, right? Over using, for example, BGP over BGP for customer routes and IGP for your infra routes. Then we discuss about what all scenarios, for example, single homing, right? And for example, multi-homing. So where we will use basically BGP. I hope this is clear for everyone.